Dear colleagues, my name is Victor Timchenko. I am professor Admiral Makarov, National University of Shipbuilding. I present report color optical computing, visualization, numbers, alphabet. My co-authors, Professor Vladimir Klinovich, University of Texas El Paso, USA, and Professor Yuri Kondratenko, Petromogila-Blaksya National University and Institute of Artificial Intelligence Problem. The development of optoelectric technologies over the past 30, 40 years has generated interest to the computing devices capable of performing binary operations and providing an alternative for all electric devices. Two main directions of optical computing: optical electronics devices using semiconductor switches for binary coordinates calculation, the construction of all optical devices of the properties of interference, polarization, diffraction, and coherence of light beam. Works of this direction show the energy efficiency of optical architecture, the structure possibility of parallel computing, high speed, and robustness of computer network with dependence. An analysis of research of field technological implementation of optical computing architecture shows of significant complexity of designing existing optical components based on physical process such as diffraction, interference, and the need to some devices to measure light waves of determining their parameters and use complex lasers as moving structural elements and well as several other implementation difficulties. Two main problems. Trends of development of optical computing allows us to identify two main problems that hinder their development and implementation. Problematic manufacturability of existing structurally complex components of optical electration and lack of systematic mathematical description for database, logical operation, visualization, output, data, and transmission of color information. Our main ideas. In the attempt to overcome these problems, the authors' development of optical computing approach, the main ideas of which are optical transformation of color, summation, and subtraction, are logical operation of disjunction and conjunction. Technologically, this optical conversion is widely used and developed. Summing up certain colors combination R plus G plus B equal white is the decision. The new decision is a light beam generated by white light source. Color is a quantum of fuzzy information. Input information is naturally converted into color quanta and produced using color field. This block diagram of inference decisions for optical color computing. This diagram of inference decision for classical fuzzy computing. The advantages of color computing when building computer network is of implementation, speed calculation, and the absence of switch elements for basic logical operation of disjunction and conjunction. Based of these ideas presented an architecture of logical gates for implementing OR, AND, NOT, NAND, NOR operation were developed. Instructions of multi-level optical network capable of performing logical operation with the big data were proposed. Thus, the goal of this paper and develop a new universal mathematical description of hybrid color alpha numeric transformation and corresponding optical color logic computing architecture covering input, output, and inference. Visualization of information by the visible light emission. The decision support system includes the information input database in the form of fuzzy information. An artificial intelligence system naturally involves inputting information just like human sensory organs. For example, the graded color with respect to concept of tapety it is proposed to trust table and numerical calculation scale to determine height of fuzzy set. This table for illustrate demonstrate degree of vertify and numerical scale. The inference generated using elementary color operation is a visible white light pattern through 3 RGB filters for primary estimates with the implementation of logical operation with exaction as well for the operation of conjunction and the form of subtractive structure. Numerical system and color. We use 3 bits for representation binary representation of color and naturally assume for absence for light black, this is correspondent to 000 equals 0. For the basin first through primary colors starting with R, we obtain 001 equal 1 and G010 2 and other combinations. Thus, the octal number system was formed. It should notice that given the idempotency property of the large information used, it is impossible to use presented optical implementation for numerical calculation. It did this, we did subtract, for example, colors, demonstrate these formulas. Suppose we need to translate alphabet, Latin and grammar into language of color. If we consider 3 bits designation for 3 primary colors, we get 27 not repeat combination. The Latin alphabet includes 26 letters, which can be identified as corresponding rather arbitrarily chosen color combination. For example, for word stands. Transformation in the numeral coding. Certain color signal received input corresponding to section 5 formulas for number. For example, for R, the first channel for filters, section 5, these filters are, we will have light radiation which corresponding to 1. In the second channel, with filter G and third of the filters B, light radiation blocking and absent, which gives 0. This formula demonstrates this mathematical description, and we have signal of output 0, 0, 1, and for demonstrate formulas for other combination of colors. This structure scheme for encoding letters and including contact blocks. The presented work proposed direction for expanding the functionality of optical color computing to solve problems in decision support system with big data. Unified approach for the format to the formation of each stage information processing for DSS from interim color information with light filters as well as, if necessary, numerical and text color information, logical inference, visualization or transmission information, both the form of color quantities, numerical codes. Quite simple design of optical devices have been developed that convert colors presentation for number and letters into numeric code. Це proposed approach based strict physical principles for the formation of optical architecture demonstrate promising capabilities for computing and encryption. Simplicity of design, high computing speed, implementation of parallel computing, high resistance of electromagnetic fields and radiation, etc. Further development of optical color computing shall be including solving the most important problems in the design of nanosite components, the development of multi-level inference network for decision support system and areas with big data, with infrastructure, facilities, medicine, and pharmaceutical and military systems for controlled moving objects, etc. Thank you very much for attention.